California has been experiencing drought for the past few years and anticipates 2016 to be another dry year. About 80% of California's water consumption goes into agriculture. The state produces over 30% of the country's nuts, fruits, and vegetables. Many of these crops are sensitive to salt. Salinity in irrigation water can lead to degradation in soil quality, lower crop yields, or even permanent crop damage. There are two solutions to this problem: overwater the soil to flush out the salt, or remove the salt from the initial irrigation water. The overwatering approach, called leaching, is what farmers are using currently, and it is a major contributor to water overuse and polluted runoff. This is highly inefficient since all irrigation water has some level of salinity, and because the warm, semi-arid climate in California speeds up water evaporation, further increasing soil salinity.
We intend to change the way farmers think about their soil salinity by giving them the tools they need to remove salt on their own. With the eddi, farmers will have a tool to understand their salt problems and act on them. Instead of flushing thousands of gallons of an increasingly scarce resource, they're able to achieve greater crop yields with only the water that they need. Desalination used to be limited to a process called distillation. In recent years, scientific advances have opened up new, cheaper ways to desalinate, and one of those methods is called electrodialysis.
In electrodialysis, an electric field is used to separate salt ions from the water. In order to divide the salty water from the clean water, the desalinator is divided into channels, and ion exchange membranes are placed between each channel. As the water moves through the eddy with an electric field applied, the salt ions will migrate into every other channel, leaving a low salt water that is ready for irrigation. The resulting salty water is recirculated into the salty channels to pick up more salt until it becomes too salty to use. At this point, it is released into an evaporation pond or storage tank, and the salty channels are refreshed with new water.
The eddi will start on its own based on a schedule, but the user can start the device at any time by pressing the on button. The eddi has a few systems working together: a valve system for controlling the flow, a desalination chamber, and an electronic system for allowing the Artik to control and sense all of the components of the device. Once the device starts, it primes itself by filling with water. No water will be flowing out of the clean pipe at this stage. After priming, the eddi starts desalinating. Groundwater flows in, its salt is removed inside the device, and desalinated water flows out to the crops. The concentrated water is recirculated during this stage and continues to absorb more salt. Once it reaches a given level specified by the user, the concentrated water is replaced by new water. After the concentrated water is replaced, the polarity reverses and the desalination process continues. This reversal washes the salt from the membranes, which is key to making the device low maintenance. There are various sensors attached to the eddi which educate users about the outflowing water salinity.
Since we have a wide audience with varying skill levels and technology, our interface approach needed to be bold, intuitive, and flexible. Designing for the feel of a native app, we structured our web app navigation to match familiar mobile icons and made the most important information as graphic as possible. Our goal with our eddi app is to empower farmers to make decisions for their crops as quickly as possible and to recognize patterns over time. To accomplish this, we built the dashboard and troubleshooting screens with clear, colorful indications of positive and negative states, and gave on-off controls as remote failsafes to minimize any risks that could damage crops. For better analysis, we provide summary graphs and exportable reports that save salinity states, flow, settings, and eventually power usage to help target efficient practices on a daily basis and over longer time frames. We hope to expand the user experience by providing more granular data settings and visualization tools in the future as we tool the eddi itself to be more efficient, more cost-effective, and easier to maintain.
You want to provide users the ability to see their water in a way that they haven't seen before, which is like how much salt is coming from the groundwater that I'm about to put onto my fields. That's something that, sure, there are probes for it, but there's no like integrated solution to be like, okay, I got this data about how much salt's in my water, like what can I do about it? What eddi offers is actually an integrated solution where not only do we provide the salinity coming into the machine, but also if the salinity is up to like an unacceptable level, we will do something about that.